The moon, our celestial neighbor, holds a secret. It's not cheese, as some once believed, but something far more valuable: ice. This ice, hidden in the moon's shadowy craters, is more than just frozen water. It's a key resource for future lunar missions. Water ice can be broken down into its basic elements, hydrogen and oxygen. These elements are the building blocks for rocket fuel. This means we could potentially use lunar ice to power our spacecraft. Instead of carrying all our fuel from Earth, we could refuel on the moon. Lunar ice could also provide drinking water for astronauts. It could even be used to grow food in lunar greenhouses. This would make long-term human presence on the moon more sustainable. The discovery of lunar ice is a game-changer for space exploration. It opens up exciting possibilities for future missions and brings us one step closer to establishing a permanent human presence on the moon. The moon's poles are home to craters that are perpetually shrouded in darkness. These craters, known as permanently shadowed regions, PSRs, are incredibly cold. Temperatures in these regions can plunge to minus 250 degrees Fahrenheit, or minus 157 degrees Celsius. The extreme cold makes PSRs ideal traps for volatile substances, like water ice. However, the darkness makes it difficult to study these regions. Traditional cameras, reliant on sunlight for illumination, are rendered useless in these inky depths. Enter ShadowCam. ShadowCam is a special camera designed to see in the dark. It's far more sensitive to light than a typical camera. This hypersensitivity allows it to capture images of PSRs by detecting the faintest glimmers of reflected sunlight. These glints come from nearby mountains and crater rims, which act like giant mirrors, bouncing sunlight into the shadowed areas. ShadowCam is mounted on the Korea Pathfinder Lunar Orbiter, or KPLO. This spacecraft orbits the moon, allowing ShadowCam to systematically map the lunar poles. By studying the images captured by ShadowCam, scientists hope to learn more about the distribution and abundance of water ice in PSRs. While ShadowCam peers into the moon's shadows, another method is being developed to detect ice hidden beneath the lunar surface. This method harnesses the power of cosmic rays. Cosmic rays are high-energy particles that constantly bombard Earth and the moon from space. These particles are like tiny bullets, capable of penetrating the lunar surface. As they interact with the lunar soil, they produce secondary particles, some of which are radio waves. Section 5. Decoding the echoes. Understanding cosmic ray signals. The type of radio waves emitted depends on the composition of the material the cosmic rays encounter. Ice, rock, and dust each produce distinct radio signatures. By analyzing the radio waves emanating from the moon, scientists can determine what lies beneath its surface. This technique is analogous to how doctors use X-rays to see inside the human body. Just as X-rays pass through skin and bone differently, cosmic rays interact with ice and rock differently, producing telltale radio signals. Section 6. The Quest for Lunar Ice. A tale of two studies. Two recent studies have significantly advanced our understanding of lunar ice. The first, conducted by Ando et al., and published in the Planetary Science Journal, focused on analyzing ShadowCam images. The second, by Costello et al., and published in Geophysical Research Letters, explored the potential of cosmic rays for detecting buried ice. Section 7. Ando et al. Refining ice estimates with ShadowCam. Ando and his team meticulously examined ShadowCam images to see if the presence of ice brightened the PSRs. While they didn't find evidence of significant brightening, their analysis allowed them to refine previous estimates of lunar ice abundance. Earlier studies suggested that water ice could make up anywhere from 5% to 30% of the lunar surface material. ShadowCam's observations narrowed this range, indicating that ice likely comprises less than 20% of the surface material in PSRs. Section 8. Costello et al. Pioneering ice detection with cosmic rays. Meanwhile, Costello and his colleagues focused on developing and testing a cosmic ray-based method for detecting buried ice. Using computer simulations, they demonstrated how radar waves generated by cosmic rays carry information about subsurface ice layers. They are currently developing a specialized radar instrument tuned to detect these specific radio signals. The instrument is scheduled for testing in early 2026, with the potential for future deployment on a lunar mission. Section 9. A future fueled by ice implications for lunar exploration. The findings from these studies have profound implications for future lunar exploration. ShadowCam's ability to peer into PSRs provides valuable data on the distribution and abundance of lunar ice. This information is crucial for planning future missions and determining the best locations for lunar bases. The development of cosmic ray-based detection methods offers a powerful tool for mapping subsurface ice deposits. This technology could help us locate vast reserves of lunar ice, potentially enough to support a sustained human presence on the moon. The quest for lunar ice is not just about scientific curiosity. It's about unlocking a resource that could revolutionize space exploration and pave the way for a new era of human expansion beyond Earth.